In this problem, we are required to find the exact length of the curve. We are given the equation y equals 1 plus 6x to the 3 halves. In order to do that, we will be using the following equation. The integral from a to b square root of 1 plus the derivative of the function with respect to x squared dx. So the first thing we're going to do is take the function and take the derivative of it with respect to x. So that gives us dy over dx equals 9x to the 1/2. Then we need to take the square of the function, 9x to the 1/2 squared, so that gives you 81x. After we do that, we input what we have now into the equation. So right here, our a is given by, our limits are given here. So our a is 0 and b is 1. So now we write it from 0 to 1, square root of 1 plus whatever we got here. So that's 81x dx. So now from here, we will be using the u substitution in order for us to integrate the function. So we're going to let u equal whatever underneath the square root, 81x, and then we take the derivative of that, so that gives you 81 dx. We're going to divide by 81 dx. So now from here, we input what we have, we substitute the u. So now we have the integral from 0 to 1, square root of u du over 81. And now that 81, since it's a constant, we can pull it out of the integral. And we're going to write square root of u as u to the 1/2 du. So now when we integrate that, we get 1 over 81 u to the 3 halves divided by 3 halves. We're evaluating it from 0 to 1. So now from here, we're going to multiply by the reciprocal of the bottom. So that gives us 2 over 243 times u. So now our u is this function right here. So I'm going to rewrite back the function in terms of x, the 3 halves, and then evaluating it from 0 to 1. So when we evaluate it from 0 to 1, we would get 2 over 243 times 1 plus 81 times 1 to the 3 halves minus 1 plus 81 times 0 to the 3 halves. So now from here, we get 2 over 243 times 82 to 3 halves minus, that gives us 1. So now this could be rewritten as 2 over 243, 82 times the square root of 82 minus 1. In this example, we're given a function y equals ln of secant of x, and we are required to find the arc length. So we will be using the equation or integral from a to b square root of 1 plus dy, the derivative of the function with respect to x, dx. The reason we take the derivative of the function with respect to x because we're given an equation of y equal ln of secant, or y equals a function of x. However, if we were given a function x equals, then we would actually take the derivative of the function with respect to y, and we would integrate the function with respect to y. So right here, the first thing we're going to do is we will take the derivative of the function. So the derivative of the function is dy over dx equals, we'll be using the chain rule right here. So ln is the outside function, so that gives the derivative of ln is 1 over. Now on the bottom, we write the inside function, secant of x, times the derivative of the inside function, and the derivative of secant is secant x tan x. Now here we can eliminate the secant, and now you're left only with tan x. So the next step is we will be squaring the derivative. So then that gives you tan squared of x. After we have the required information, we are going to input our stuff into the function. So right here, the integral from a to b is the integral from 0 to pi over 4. Our conditions are given. The square root of 1 plus, we solved for dy dx squared, so we put tan squared of x dx. Now 1 plus tan squared of x is a Pythagorean identity, which is equal to secant squared of x. So we can rewrite that as secant squared of x dx, and that would give us from 0 to pi over 4 secant x dx. Now from the integral table, we have the integral of secant x dx, and that is ln of secant x plus tan x, and we evaluate it from 0 pi over 4. And now we input our condition, so secant of pi over 4 plus tan of pi over 4 minus ln of secant of 0 plus tan of 0. Now using the unit circle, we know that secant of pi over 4 is 2 over square root of 2, and tan of pi over 4 is 1 minus ln secant of 0 is 1 and tan of 0 is 0. Now don't forget that secant is the same as 1 over cosine. So on the unit circle, you would look for the values of cosine, and then you would just place that value 1 over the value. And then here we know that this right here, when we evaluate it, gives you ln of 1, which is equal to 0, so it makes this whole function 0. And now here we can rationalize the denominator. Then you would have ln squared of 2 plus 1.